All right, Algebra 2. Welcome back. We're going to continue our talk about exponents today, and specifically solving equations. So we're going to move into 9.4 notes, and this is solving exponential and logarithmic equations. These are super fun. So a couple of things I want to show you first of all here from your printout. If you don't have these copied down, it might be good to just remind yourself. If a to the x power equals a to the y power, then x equals y, okay? So that's our first one. If a to the x power equals a to the y power, then x equals y. So know that when we're solving an equation, same base is very important. So we're always looking for same base. Come on, screen, you can do it. All right, there we go. And then for logarithms, it's very similar, remember, because a log is an exponent. If log base a of x equals log base a of y, remember your bases have to be the same, then x equals y. So we're going to keep those in mind. Same base is muy importante, right? So that's the key here. We're looking for same base. Let's look at some examples here. We're going to start using those properties of logs that we learned about. And don't worry, we're going to spend a couple of days on this. So if it's super confusing now, that's okay. We're going to continue with it. Here's example 1. Here's A. So it says 4 to the x plus 2 equals 4 to the 5. So it's going to follow our property up here, or our rule up here. Our bases are the same, they're both 4. So my exponents are going to be equal to each other. X plus 2 equals 5. Just going to continue to solve how we normally would, and x equals 3. We can check this by plugging it back in. 4 to the 3 plus 2 equals 4 to the 5th power. 4 to the 5th equals 4 to the 5th. That checks out. Beautiful. All right, let's look at example B. Natural log of 2x minus 3 equals natural log of 11. Remember, natural log is log base 10. So same goes here. If I have a base of, or log base e, sorry. If I have the same thing, then they'll equal each other. 2x minus 3 equals 11. Solve it just the way that you normally would. 2x equals 14. X equals 7. All right. So I'm going to show you a different way to check this answer besides. Okay, so I've plugged in my functions here, and we found our answer to be 7. So we're checking to see if this is correct. Now, anytime I just have a number, right, I want to just put in y equals. So because log base e to the 11 is actually a number, you can figure that out by putting it in your calculator, then we need to put a y here. Otherwise, this is a function, right, because it has an x in it. All right, so I'm going to look for their intersection point here for my x value, and look at that. The answer is 7. So that's another way for you to check your work. All right, let's move back to our notes and do some more. Here's example 2. We're getting just a little bit more curious about this. So we're in example 2. This is A. 3 times log base 10 to the x equals 6. Okay, so a couple of things here. Your first step, notice on the other ones that your logs or your exponents were already isolated, right? So that's not the case for these. We have to isolate our logs first or our exponents first in order to find our solution. So to do that, I'm going to divide by 3, right? So we have log base 10 of x equals 2. And because my x is here, I'm going to go back to my log and exponent properties And remember when we said log base a to the x equals y, converting that to an exponent is a to the y equals x, right? So we're going to do that same thing here. I'm going to rewrite this as an exponent and maybe I can get a good answer. So 10 to the 2 equals x. Well, 10 squared, I can figure that out. It's 100, right? So x equals 100. We can check that by placing it in Desmos to see if we're correct. I'm going to move on just for time's sake. Same thing for b. 2 times the natural log of x equals 5. So I'm going to divide by that 2 first to isolate the natural log of x equals 5 halves. Now, how do I rewrite this as an exponent? That's a great question. Let's remember that natural log is log base e. And so I'm going to rewrite the others just the same way, right? So now I can rewrite it as an exponent. E to the 5 halves power equals x. Well, lucky we know that e is our constant number. So let's get our calculator out. All right, I got my calculator here. I'm going to plug in that e value raised to the, maybe put parentheses in, 5 divided by 2, and we get 12.182. By the way, when you're in Desmos, just putting in E will get you that number automatically. There's not, I don't know if there's a function for it there. Is there? Oh yeah, here it is. All right, but you can also plug in E. Okay, so let's look at letter C. We'll use our other property. So this property we used, ln is the same as writing log base E. All right, so let's look at C. We have log base 6 of x plus log base 6 of x minus 5 equals 2. All right, so let's think back to our properties of logarithms and remember that a log is an exponent. So when we're adding exponents, we're multiplying, right? We're actually multiplying. My bases are the same, so I can write this as log base 6 of x times x minus 5 equals 2. So this is log base 6 of x squared minus 5x equals 2. So let's see. Now I'm going to, so this was our product property, just FYI. I'm going to write that out here. Log base A of m plus log base A of n equals log base A of m times n. All right, that was just an FYI. Now I'm going to use this to go back up here, whoops, and rewrite as an exponent because there's no way I can figure this out. I could figure it out here because this is actually a number, right? Can't figure it out here because x is here. So we're going to rewrite it as an exponent. 6 to the second power equals x squared minus 5x. Oh my gosh, now we're really going to have to go backwards in math. We have 36 equals x squared minus 5x. Oh, when we have an x squared and an x, we get everything on one side and we factor, right? Remember that? 0 equals x squared minus 5x minus 36. Let's see what this can factor to. It looks like 9 and 4. This one's negative, this one's positive. Got x's all around. All right, so x minus 9 equals 0, x plus 4 equals 0. So my answers in this case are x equals 9 and negative 4. I'm interested to see if I have any extraneous solutions. So let's pull our graph out because that's my favorite way to check answers. We'll pull our Desmos graphing calculator out and we'll plug these in. So on one side, we're going to write log base 6 of x, close our parentheses, plus log base 6 of x minus 5 And then on the other side, we're going to write y equals 2. Okay, so we had two answers, right? 9 and -4. It's looking like our vertical asymptote here is at 5, which would tell us that here, right? That still tells us where our vertical asymptote is. And 9 works. 9 is an intersection point. However, -4 is not an intersection point. So guess what? We have an extraneous solution. So we're going to have to write that down. -4 is our extraneous solution. All right, so let's look on the next page. We're going to be talking about our change of base formula. Change of base formula, and this is kind of FYI for next time. What happens if I'm using the calculator and I want to calculate something, but my base is not 10? Remember we talked about your calculator only reads base 10, and we hit it here, right? There's not really, sometimes some calculators allow you to put in a different base, like the Desmos here. It allows me to put in a different base for the graphing part. But in my Desmos calculator here, it doesn't let me do that. It automatically reads it as base 10. So let's keep that in mind. And there's a change of base formula to use when my base is not 10. I need to calculate something, right? So when log base b of a equals log base 10, right? Because that's how your calculator reads it, of a divided by log base 10 of b. This is how I think about it in my mind, and don't let this confuse you. This number is always bigger, right? In size, not amount, but or value, but size, and this one's smaller. So I always think, okay, I got to put the big number on top. Size, not value. If that helps you, if it doesn't, then don't worry about it. All right, let's try this. We have example 1 here. So we have log base 2 of 10, and I want to find this value. So I'm going to say, okay, log base 10 of 10 divided by log base 10 of 2. Let's see what that is. So log 10 divided by log of 2. And look at that, we get a value, 3.32. So this is just kind of an FYI in the middle of us solving these equations, because we'll probably run into some equations where you need to solve it using a different base. We need to know how to do that. All right, let's try this one. Log base 7 of 11. So we're going to say log base 10 of 11 divided by log base 10 of 7. 11. I love 7, 11. All right, so let's see. Log base 8, or log of 11 divided by log of 7. It's not very complicated to use. Just need to know about it, right? So 1.23 we can write as our evaluation there. All right, so that concludes our, we're going to practice these in class today. So come prepared with these, and we'll do them all together, okay? See you soon.